Which carbon of nitrobenzene gets more electron density? Which carbon of nitrobenzene gets more electron density? This is carbon with substituent, orthocarbons, metacarbons, or paracarbon. Let us try to find. The question is related to nitrobenzene. Let us write structure formula of nitrobenzene. This is benzene, and at this carbon nitro group, this is nitrobenzene. Here this bond is coordinate covalent bond. Nitrogen oxygen bond is coordinate covalent bond. Now let us name the carbon atoms of nitrobenzene. The carbon with substituent is numbered by 1. Then this is 2, this is 3, this is 4, 5, 6. This is one process to name the carbon atoms of nitrobenzene. Carbon with nitro group is named by 1, and then 2, 3, 4, 5, 6. There is another way to name these carbon atoms. The carbon atoms nearer to the carbon with substituent are called orthocarbons. This is orthocarbon. This is another orthocarbon. Carbon atoms nearer to the carbon with substituent are called orthocarbons. Then carbon atoms farther to the carbon with substituent are called metacarbons. This is metacarbon, and this one is metacarbon. Carbon atoms farther from the carbon with substituent are called metacarbons, and carbon atom farthest from the carbon with substituent is known as paracarbon. Now let us see which carbon atom gets more electron density of nitrobenzene. Which carbon atom of nitrobenzene gets more electron density? Let us see resonance structures of nitrobenzene. Nitrobenzene. This oxygen nitrogen bond is the source of resonance structures. Here electronegativity of oxygen is 3.5, but nitrogen's electronegativity 3.1. So these covalently bonded electrons, pi electrons, move towards oxygen, and as a result this structure is obtained. It becomes negative in charge. Nitrogen becomes positive in charge. At the same time, these pi bonded electrons move between nitrogen and carbon. It becomes a double bond, and other pi bonds remain unchanged. This is one resonance structure. Another one, and here this carbon becomes positive in charge. Because of this positive charge, pi bonded electrons move here. Then we get this structure. Oxygen negative in charge, nitrogen positive in charge, here double bond, and it becomes double bond, this is double bond, and para carbon becomes positive in charge. Then negative in charge, positive in charge. Here, due to this positive charge, these electrons move here and this carbon becomes positive in charge. Double bond, this ortho carbon becomes positive in charge. Then, because of this positive charge, here double bond, these electrons move here. At the same time, these electrons move here to form again oxygen nitrogen double bond. That is, this is obtained. Double bond here, here double bond. That is, previous structure is obtained. Again, it becomes this and so on. That is, resonance hybrid we can draw in this way. Nitrogen, coordinate covalent bond, oxygen, here this oxygen is partially negative in charge, this is partially positive in charge, and partial oxygen nitrogen double bond. Here partial nitrogen carbon double bond. Here movement of electrons. This carbon becomes partially positive in charge, that is ortho carbon. Then para carbon becomes partially positive in charge, and then another ortho carbon becomes partially positive in charge. That is carbon 2 and carbon 6 become partially positive in charge, and carbon 3 and carbon 5, that is meta carbons, become electronically rich comparatively, and para carbon becomes positive in charge. Para carbon or carbon 4, positive in charge, positive in charge, positive in charge. But this carbon and this carbon, that is carbon 3 and carbon 5 or meta carbons, get more electron density comparatively. That is, meta carbons or carbon 3 and carbon 5 gets comparatively more electron density due to resonance of nitrobenzene. Thank you for watching.